And my thanks to Luna Lee for playing us in as always. Please do check out her website and her YouTube channel. And as I say, we're really lucky to actually have such a talented musician for our intro and outro. Right. Okay. So welcome to CometWatch. It's August 23rd. And okay, we're a day late, but I have a good excuse. I've been ill. So we'll leave it at that. So as always, my name is Nick Yvetz, KC2BWR or 2E0LUN, and my co-host is
John Meichner, Observatory Code W62.
So as always, we're going to start the show with the shipping forecast. As always, my thanks to both Nick James and Jonathan Shanklin for access to the Comet section visual observations page. And the latest discoveries and news will kick off with a July the 8th recovery of 2005 S2 periodic skiff as 2025 Oscar Zulu 695 reported.
July 8th, Yang Yu reports a Kreutzschugh comet and CCOR1 images.
Again on July the 8th, Eric Banach reports a Kreutzschugh comet in CCOR-1 images.
July 9th, Washa Blue Plot reports a Kreutzschugh comet and CCOR1 images.
July the 9th again, Diego Ruan reports a Kreutzschugh comet in CCOR-1 images.
July 9th, recovery of P12 2012 K3 P Gibbs reported.
July the 12th, Diego Ruan reports a Kreutzschugh comet in CCOR-1 images.
July 14th, cometary activity reported in 875163 in 2025 September.
That must be an asteroid that's turning into
a that's an asteroid.
Yeah. Okay. Discovery of 2026 M3 Master reported.
Michael Stark reports a Kreutzschugh comet and CCOR1 images.
Now, I wonder, is this guy related to either Tony Stark or Nathan Stark? Okay, it's a Marvel versus Eureka thing. Recovery of July 15th, recovery of 2006 HR3 as 2026 M4 reported by MPC.
Yang Ru reports a Kreutzschugh comet and CCOR1 images.
July 21st, Yang Ru reports a Kreutzschugh comet in CCOR-1 images.
July 22nd, Yang Ru reports a Kreutzschugh comet in CCOR1 images.
July 22nd, Warchart Boomplod reports a Kreutzschugh comet in CCOR-1 images.
July 23rd, CCOR2 images are available from the operational Solar 1 spacecraft.
July 23, Diego Ruan reports two Kreutzschugh comets in CCOR-1 images.
July 24th, Yang Ru reports a Kreutzschugh comet in CCOR1 images.
July 25th, Diego Ruan reports a Kreutzschugh comet in CCOR-1 images.
July 26th, recovery of P2013 T2 periodic comet Schwartz reported by Maker Meyer.
Oh boy, there's a joke in that one as well.
Yeah.
Right. Oh yeah. July 26th, Enric Brandt reports a Kreutzschugh comet in CCOR-1 images.
July 27th, Yang Ru reports Kreutzschugh comet CCOR1 images.
July 27th, Rainier Kracht reports a Marsden comet in C2 images.
July 28th, Eric Branch reports Kreutzschugh comet in CCOR1 images.
July 28th, Diego Ruan reports two Kreutzschugh comets in CCOR-1 images.
July 28th, Michael Stark reports a Kreutzschugh comet in CCOR1 images.
July 28th, Michael Stark reports a Kreutzschugh comet in CCOR-2 images.
July 29th, Michael Stark reports a Kreutzschugh comet in CCOR1 images.
July 29th, Diego Ruan reports a Kreutzschugh comet in CCOR-1 images.
July 30th, Eric Branch reports a 9-group comet in C2 images.
July 31st, Diego Run reports a Croix-Group comet in CCOR-1 images.
August 2nd, Modular reports a Kreutzug comet in CCOR2 images.
August the 2nd, Diego Run reports a Maya comet in CCOR-1 images.
Zhang Ru reports three Kreutzug comets in CCOR1 images.
August the 5th, Diego Run reports 2 Croix-Group comets in CCR1-1 images. And August the 5th was also when the page was updated. If there haven't been any recent update, you can always try the German Comet Group or Seiichi Yoshida's page. Or it goes to the Liga Iberoamericana de Astronomia for observations. Okay, so we'll move on to the really fun part of this, the current comet magnitudes and observable region for 2026 August. You can start, John.
Okay. Comet 2220P McNaught, 7th magnitude trending outburst, observable from 55 north to 70 south, best in the morning, last observed August 2026.
10P Temple, 8th magnitude, steady, 55 degrees north to 90 degrees south, best in the morning, also last visually observed August 2026.
Comet 88P Howe, magnitude 13, fading, observable 55 north to 55 south in the morning, last observed July 2026.
29P SW1 or Schwarzmann-Wachmann, I hope I got that right. 13th magnitude question mark, varies 5 degrees south to 50 degrees south. It's an early evening object, sorry, and is last visually observed 2026 May.
Comet 78P Gales, magnitude 13.5, steady, observable 30 north to 15 south, visible early morning, last observed July 2026.
2025 R3 Pan-STARRS, 13.5 fade, poor elongation, last visually observed June 2026.
Comet 2024 T5 Atlas, magnitude 13, bright, observable from 10 north to 70 south, visible early in the morning, last observed July 2026.
169P NEAT, 14th magnitude, bright, 55 degrees north to 25 degrees south, all night when visible, not yet observed.
Comet 2023 R1 Pan-STARRS, magnitude 14, fading, observable from 45 north to 70 south, visible in the evening, last observed July 2026.
2024 J3 Atlas, 14.5 magnitude, steady, 55 degrees north to 15 degrees south, all night, not yet observed.
Comet 161P Hartley Iris, magnitude 17, bright, observable from 25 north to 80 south, visible in morning, not yet observed.
And finally, 34D Gale, magnitude question mark, bright, 40 degrees north to 80 degrees south. It's an evening object. This is interesting. This has not been observed since 1938. Wow. So anyway, details are normally updated at the beginning of every month. Some minor updates may be more frequently, particularly for brighter comets. The last partial update was on the 3rd of August. As always, the magnitude is a rough value for the mean magnitude reported. Some observers will obviously see the comet brighter than this, while some will see it fainter. As always, the observable region is an approximate indication of the latitude at which the comet may be seen by a visual observer. Under good conditions, obviously, it will be visible outside this range, especially when imaging. So the period when visible is for the UK. If the comet is visible from the UK, otherwise for 30 degrees south or the equator as appropriate. This is the last visual observation as received by the BAA Comet section. Details are often updated on the basis of observations published elsewhere. Most beginners will find comets fainter than about 7th magnitude difficult to locate. The BAA Comet page does have some excellent information on positions and finder charts available. So, okay, the take home from this month is 220p Mach naught is in outburst, and having seen some of the pictures, I can agree with that. What do you think, John?
It's been very bright. I actually detected it in binoculars, and I made a couple images on it. And it's a very spectacular comet. It's overachieving this opposition by far.
It's always nice when they actually do that, because it's magnitude 7 question mark. So it's kind of good, really, because this is potentially a good comet for beginners to look for in the sky, and certainly a good one to try and image. I've imaged it on a couple of occasions already, and to say it's being spectacular, I think is an understatement. And of course, the other one is 10p Temple. That's getting close to its peak brightness. So again, that would be another one to look at imaging and looking for. That's only 8th magnitude. The trend for that one is fairly steady. So again, look for the appropriate finder charts, and you should, with luck, either get to see it visually through a telescope, or image it. And I'm going to be honest, I don't think anything smaller than 6 inches, I think you're going to have problems, particularly with some of the fainter comets that we've mentioned tonight. Okay, well, unfortunately, our guest can't make it this week, but I did find there's an interesting paper out there that's published this year, looking from what I can see, and it's called the Interstellar Comet Explorer Architecture, a modular Lagrange-Point Sentinel and Interceptor framework for interstellar object detection and characterization. Now, we've all discussed wanting to be able to send more probes to these comets, and I think this paper sets out quite nicely how to do it. Although, admittedly, it is really looking for interstellar visitors like Mura and 3L Borisov. Have you had a chance to have a look at the paper, John?
Yeah, I did. It's a very interesting white paper they put out. Obviously, they talk about a number of technologies there, and I can see where one thing I always was curious is this black star. And I said, oh, I'll go back and figure this out. And of course, two of the authors are dealing with this black star orbital technique, or actually ship they're trying to build
Yeah.
to more or less probably use for this technology and other technologies. But it hasn't been, I'm not aware of it being launched or even prototyped at this point, really.
Well, yeah, because the only thing we actually know about, unofficially, officially, is the unmanned spacecraft that's being used by the Department of Defense. Sorry, I'm going to say it's the War Office now. Sue me.
Whatever.
Yeah. And that comes and goes on whatever missions it does. So I'm wondering if this Black Star project is maybe an outgrowth of that.
Yeah, I think it is. It's probably going to be would have to be bigger than the X-37, which the Department of whatever is using right now for covert activities. But they're obviously going to make something very similar. I think Lockheed developed either Lockheed or Boeing developed the X-37. So, and that's been flying for probably over 10 years at this point, very successfully.
Well, it's obviously to some degree reusing space shuttle program
Yeah, it
technology.
is essentially using that.
It's unmanned, and in a lot of respects, it is probably a very good prototype for getting equipment into space and into position. So theoretically, it could actually be also used. Maybe 2 or 3 of them could lift components to high Earth orbit, possibly, or even low Earth orbit for assembly, because the amount of reaction mass needed to leave orbit is going to be a heck less than punching something completely built from the ground at Cape Canaveral or Karuru, or even from Woomera. So yeah, we could see this potential. I guess we could see potentially this could be built in space by a space station crew sent out to the relevant Lagrange-Point and set in place. So when it detects either a interesting visitor from this to our solar system from another one, an interstellar object, and I need to correct myself. I said 3 Borisov, it's 2 Borisov, because I believe 3 was Atlas.
Atlas, yes.
Yeah. So anyway, you go back into the history of the show. I got this. I did a similar thing with Cahutek's Comet and Comet West during the Skylab mission. So every now and again, I do these things. But yeah, I really like the way they set out the potential for supporting ESA's Comet Interceptor missions. And I think,
Yeah.
Go on, John.
Yeah, I agree with you.
Because basically the idea is at the moment on paper, it's 3 spacecraft. Obviously, with the developments that they're talking about here, it means that we have the ability to put more than 3 spacecraft into position. So no matter what happens, so we could potentially even say, okay, we can go to the Jupiter family of comets and have a nose around there. And then we can, if we see another interstellar object coming in, we can actually get close to it and do a flyby mission. And I think with some of these interstellar objects, this would be very, very good, if only ever to debunk some of the insane theories about there being ancient spacecraft. I know we had that one with the first one, and everybody was jumping on, oh, it's like Niven's ring world. Whatever. There was no signals coming from it that indicated intelligence. If it's a space probe, it wouldn't just be passive, I don't think. If you're going to send a space probe into somebody's solar system, you're going to want to have an active sensor suite so that you can sample much, much more and find out what is going on in the target solar system, particularly since we've sent our television pictures by now beyond the solar system. Certainly the stuff from pre-World War II is getting out there. They're low-grade signals now, but they are out there. And so anybody, if there is intelligent life, is going to receive them. And I really hope they don't come, because I think they're going to find us very distressingly primitive at the moment. But it does mean with the next interstellar visitor, we can look at them in depth, whether it's a comet, an asteroid, or whatever. We can now finally see what is coming through the system. And I think there must be, on even some of the most elderly photographic glass plates, some of these visitors, they just haven't been picked up because nobody was looking for them. So who knows what is actually hiding in the archives. We've had 3 we know of because we've had the instrumentation to detect them. When I think they would have probably been very, very difficult to detect on an exposed glass plate. I could be wrong, and if you are one of the scientists that's on these archives, if you can let us know whether or not they could have been detected, that would be great. But I think the ability to detect something on the earlier photographic plates would have been very, very difficult. But anyway, so looking into this paper a little bit further, it proposes the interstellar, and they say clearly this paper proposes the interstellar ice architecture as a modular deep space infrastructure concept to support persistent interstellar object detection. And of course, the other thing is, in 2029, there's going to be a close approach from 99942 Apophis. So this could be a real world validation opportunity for distributed tracking, persistent observation, ephemeris refinement, communications rehearsal, and coordinated operational response. We know Apophis' orbit pretty well. I think that's standard agreement, yeah?
Yeah, definitely.
So it would be a perfect target to use. And again, the data or data, potato, potato, really would be even better. The more we can get on these near Earth objects, the better it helps the planetary defense team at NASA to be able to deal with anything that could come, and potentially, I'm going to say potentially, because we know that somewhere out there in the future there is either an asteroid or a comet with this planet's name on it. We can't avoid the fact. The last mass extinction through an object from space was Chicxulub. It wiped out the dinosaurs. So saying that there isn't ever going to be another one, I think is foolish. But the fact that most of the world now has decided to plan for these things and track these objects is all to the well and good. So if this proposal goes ahead, it would give us an opportunity to practice and hone our skills. Do you have any thoughts on this, John?
Yeah, it would be very interesting if it could, get some interest. But as you're well aware, the United States they used 10-year decal surveys to figure out what they're going to do. So it would probably be after this Apophis potential rendezvous. So that would probably have to wait until the 2030s or some other object to do something with. But there's always other asteroids that are making close approaches they could use this for. So, but they use the most obvious and easiest one that would be visible, essentially.
Yeah.
Maybe the Europeans would be more, or the Chinese would be more easy to do a project like this than the United States at this point, really.
Well, we have been very successful in multi-agency projects.
Yes.
So even if this was picked up by, say, the European Space Agency, and they looked for input from NASA, from other space agencies, JAXA, and everybody else, even if everybody's putting in a small contribution to the end game, it would mean no one country is literally paying for a very admittedly expensive space mission.
Yeah, it would be very expensive.
But like I say, it would be a very interesting prospect. And I think even if we miss the 2029 Apophis window, there are going to be other windows.
Right.
And I think in the planetary defense stuff, I've seen, as part of an asteroid day event, I've seen the drills that the planetary defense teams do. These aren't just the United States doing it on their own. These are multinational teams all getting together in one building, and basically it's like a giant game of Dungeons and Dragons. They are literally gaming out the possibilities. And I think in a lot of, I think again, that is very positive because it means that there is a multinational awareness that just because if a 5 meter piece of rock hits, oh, let's say Liechtenstein, is not just Liechtenstein that's going to suffer. We saw what happened with Chicxulub. We've modeled that very effectively. So we kind of know, yeah, okay, so Liechtenstein gets hit. I'm not picking on you purposely, Liechtenstein. It's just the first country that popped into my head. But we can see what will happen and we can mitigate. And that's what it's going to be, mitigation. We've had a very successful test of DART, even if it had a slightly unexpected result. So we know that that works. Let's keep the deep impact stroke Armageddon methods out of it for now because it's illegal. The 1960, I think it was 63 or 66, Outer Space Test Ban Treaty prohibits the use of nuclear weapons in space. Ironically, it also prevents the use of nuclear-powered space drives. So we can't use nuclear weapons in a good way to push a rocket or spacecraft closer to the speed of light, because the test ban treaty would have to be totally renegotiated. However, NERVA and Project Orion, which are now declassified from, I think, the late 1940s, 1950s, proved that nuclear propulsion in space was highly feasible and actually could be used to perhaps get into the solar system a lot faster than maybe using a chemical rocket, which would have to be refueled. It's kind of like going to Mars. When you get to Mars, you've got to have your refueling station waiting for you. Now, whether you're going to do it by sending a spacecraft that's chock full of fuel, or you're going to make your own fuel on Mars before the astronauts arrive, is the option. So we do have options. And I know everybody goes, oh, Mars is planet B, plan B. It doesn't have to be that way, I don't think. And I think projects like this will certainly make things a lot easier for us down here on planet Earth. Never mind the science we're going to get back from going to these objects. And I think that's what a lot of people forget. Oh, it's just a black hole for money. No, it's not, because these projects teach us about the solar system. They teach us how it came into existence. And I think also it opens up resources to the human race. We know that Titan is chock full of petrochemicals and methane. We have water in abundance in the solar system. We even have it in large quantities on the moon at the South Pole, in the shadow craters. So, and that's one of the biggest things that they need to put a manned base on the moon, is ample supply of water. You just can't keep launching rockets full of hydrogen and oxygen, or even water, because it's horrendously expensive and it's weight prohibitive. But anyway, who knows? Maybe we will get something interesting out of this paper and we'll get some interesting science. Anything cropped up you've seen that I may have missed?
No, I think you hit all the points there. I agree. Hopefully, that somebody will take the reins and do a mission or a profile like this, either like this or something different to explore, incoming interstellar objects, essentially, because we really need to understand more about them than just speculation and what we've been able to generate over the last 3 interstellar objects. We've developed a lot of information from 3I Atlas. That was a treasure trove and the amount of time that we had the images was quite a long time, and we were able to put a lot of resources into imaging that object, not just professionally, but also the amateur societies and group of people did a lot of imaging. I did a lot of imaging of 3I Atlas. I know that, and a lot of people in CometWatch posted a lot of images of Atlas over the last year.
Well, I think this is where amateur astronomers do come into their own. As I've often said, we have the instruments, we have the tech, and we have the time. And whereas in a lot of cases, scientists can't always get the amount of time they want on the big optical telescopes or the HST or even the James Webb. We can do that from Earth, and we can provide scientific information exactly to the quality that's required.
Definitely.
So I don't think ever that the amateur astronomer is ever going to be out of a job. As instruments become available, who knows? We could actually see maybe some of these remote telescope companies coming together and paying and putting into orbit a space telescope. Lord knows, the mirror blanks still exist. There's still mirror blanks out there that could be used for an optical telescope. And who knows what you could do with a near infrared, ultraviolet, or even a infrared telescope. As an amateur, we have the filters to use, but the atmosphere is against us. It filters out most of this stuff. Unless you're, of course, you're lucky enough to own an observatory on a very tall mountain, and you have to remember to take your own oxygen supply. But getting access to places like that are difficult. Mauna Kea is full telescope-wise, so I can't really see us being able to put a telescope up there. But there may be other mountains we can use. I tend to think most of the professionals have got them all staked out anyway. Certainly Mount Teide springs to mind in the Canary Islands. One remote telescope company already has a presence there. I'm surprised nobody else has tried to do it. But that's something else. The remote telescopes provide a huge network for amateur astronomers to use as well. Can you think of anything else we need to touch?
No, I think we hit a lot of the high points of this paper. Are you going to post this?
Oh yeah, I will put a link to it. Now, I got my copy of the paper from Academica.com. Hang on, let me just go back here. So I will put a link into the show notes. You certainly can get the extract without any problems. And I believe they allow you to download one paper a month in full. The reason I know this is because I've been downloading a whole bunch of Martian maps. Again, this is something I would like to be able to start doing properly, is imaging Mars. And if I've got the mappings that a lot of the professionals have been putting up, then that will help me as well. So therefore, you can sign up for a free account. You can download one paper a month and build up quite a collection. That's exactly how I do it. If I see there's a paper that's really caught my eye, I will go to this place, look for it. If they've got it, or if another institution's got it, but because I've got an account there, I can normally get it. You can normally get it that way. Doesn't always work, but it does sometimes. So, or if you've already got a student account with your local university or college, that may let you in as well, and you can get the whole thing. But anyway, I will put a link to this paper into the show notes, and I would be interested to see what everybody else thinks about this. I think it's got a lot of promise, and if it happens, even if it happens in the 2030s, I think the rewards for planetary science and cosmology are going to be great, particularly if we can actually get up close to one of these interstellar objects and really look at it and really do the science we need to do at all wavelengths. But anyway, that's certainly what I think. Um, and yes, please do leave some comments once you've had a look at the paper and what you think. We would be very interested. John, how's your imaging been coming along?
Well, been whenever it's clear, like tonight will be a good one. I have a number of comets I'll be going after tonight. Uh, it's been interesting the last couple sessions. I was able to, get the Comet 2005 skiff.
Yeah,
Recovered that via an amateur. The only thing was being image picked up those as the big scope. So I decided, hey, give it 2.5 hours and see if I can get down to that magnitude. And sure enough, I was.
mhm.
So, and I like going after some of these really challenging faint ones, especially when the big boys are spending some time doing it. I said, we'll do that.
Well, I think the two I'm trying to currently image, one is 29p, but it's not simply not available at the minute to the telescopes I use.
But isn't it pretty early evening at this point?
Yeah, it
Being
is.
interfered
But
by, it would be in the twilight almost.
yeah, and most of the scopes are still closed. But they only start to open in astronomical twilight. So, and they won't start imaging until full dark.
Yeah.
The other one is 2025 R3. I've been chasing that for a while. And every time I've actually managed to get um, a imaging run sorted, the weather gods have come along and said, ah, ah. But that's part of life.
Yeah. I tried going after 2013 T2 Swartz a couple weeks ago, but I couldn't really detect it. But I only gave it an hour's worth of imaging. I think it's going to take 2 hours of imaging to get that. But that's going to be a tough one. And one thing I was surprised to see is that one comet they had on the BAA Comet 340 Gale. It hasn't been observed from 1938.
Yeah.
Why was that on there?
34D Gale.
Yeah, yeah, that's just
Right.
weird.
Yeah, I know.
It didn't I said 2000? I mean 1938. Wow.
Yeah.
Just
Right. Well,
I didn't understand that one at all.
okay. It was originally discovered by Walter Frederick Gale on June the 7th, 1927. Nearly said 2027. And it's not been observed for 87 years.
Yeah,
Second apparition was calculated for 1938, but Gale failed to find it.
yeah,
However, it was recalculated by Leland E. Cunningham, who recovered it for that year. That's according to Wikipedia. Now, this is also a Jupiter family comet. So roughly 11 years. Maybe it got perturbed. Yeah, it's certainly interesting. In the sky.org. From mountain view, 34D Gale will be visible around 2018 Pacific Daylight Time, 22 degrees above the southwestern horizon. In fact, Gideon van Buteren has a chart for it. Let's have a quick look at this. Perihelion is in 2 days. Magnitude 10, he reckons, at 1.213 AU. Elongation is 71.4 degrees. Phase 52.1 degrees. Radius 1. Interesting. Yeah.
Weird thing.
Definitely strange.
Yeah, it is
But
definitely.
it definitely looks like it's been very, very close to Jupiter, according to the orbital track. So yeah. That's going to take it close. Looking at the orbit, it's going to take it close to Jupiter again. In fact, it almost goes out to Saturn.
It goes past Saturn.
No, almost too. I'm looking at his orbital interactive orbit chart. And it's going to go all the way out.
Just
almost.
about, yeah, just about, almost.
Yeah. And it'll come back in again. But it comes into. Oh, that's interesting. It's going to be inside the orbit of the Earth and Venus. Right, so it has been already, and it's now heading out towards Mars. And that is as of today. I will put this into the links, but it might be worth trying to see if this can be found using remote telescopes as well. Yeah, it's definitely worth a thought. But it's an interesting orbit. When it's after it's been close after perihelion, it's clipped the orbit inside the orbits of the Earth. Interesting. Very interesting.
Yeah, certainly had a close approach.
Yeah. Yeah, looking at.
Surprised if it was invisible, some of the big telescopes haven't picked it up at this point, really.
I wouldn't be surprised. Because it looks like it's coming in from the southern hemisphere. If you play with the interactive orbit, it looks like it's coming in beneath the Earth over Venus as it heads out and crosses over the top of the orbit of Mars. And then it got it going over the top of Jupiter out to Saturn.
Yeah.
Yeah, that's definitely interesting. Maybe this is something we should be keeping an eye on. Let me see. +1. So it's definitely clipped the Earth, the orbit of the Earth. It's just gone inside. Does it? Maybe it doesn't. Very hard. Yeah. Very hard to tell. This is what I'm looking at. Let me just message you this, John.
What program are you looking at right now?
I just popped it on Instant Messenger.
Oh, I mean, what app are you looking at the orbit with?
It's actually Van Buteren's own website.
Oh, okay. I'm looking
Actually,
at I'm looking at JPL.
yeah.
JPL, it doesn't cross the Earth uh, orbit. It's between Mars and the Earth.
Hmm. Maybe it's just the actual the way it looks on the 3D representation. Anyway,
Try the JPL. That might be a little bit better.
right.
I just sent you the JPL. Hopefully, that will come up.
Ah,
I'll look at yours. Yeah, yeah. This one doesn't. It doesn't. The one from Van Buren doesn't have it crossing the Earth's orbit. So again, it's in
yeah.
between Earth and
Well,
Mars.
I'll put both of these links into the notes
Yeah.
so everybody can have a look and a play with it as well. It is definitely interesting. You are an interesting little thing, aren't you? 34D.
If it's up and I'm okay, I might take a quick couple of images. I doubt it. I doubt I'll be able to recover it.
Yeah,
Plus, it's minus 22 deck, so
yeah.
oh no, this thing's not visible. It's RA is 14 hours 31 minutes.
Yeah,
So that's in the early evening sky.
yeah.
Yeah, it's in the evening sky, like right after. Yeah,
So everybody's going to have a problem looking for it.
it would have to be early morning. I mean, early evening.
Still, it's an interesting little comet,
Yep.
and if it can be recovered properly, it would be definitely be interesting to see what people get
Yeah.
image wise.
Yeah.
Right. I think that's a nice just over the hour. So
Yeah.
I think that's a nice little show for this month, and hope we'll be back next month around the same time, the same back channel, so to speak.
Yeah. Definitely.
Anyway, I'm sorry, I shouldn't let my sense of humor get carried away, should I?
Well, you can have a sense of humor. There's no problem.
So anyway, so we'll wrap the show now, and we'll start work on next month's show, probably about the same time of the month. In fact, let me just have a quick look at the calendar, because I know I've got some time off coming up next month. So we're looking at the 19th or even 25th. That would work. Right. We will get onto this. So anyway, as always, thank you for coming, John. I always appreciate you to talk to. I love being able to bounce stuff off you.
Definitely. It's really good.
So I guess it's good night from me
Yep. Everybody else have a good night and good imaging.
and clear skies.
Take care.
Take care.